This is a talk that I'm super eager to hear, and Adam, we'll get out of your way and let you take it away, okay?
Awesome. Yeah, I on all this, I do think we'll get that, but I think code execution maybe is that next step of like, wow, this is going to unlock way more from MCP, with hopefully server developers not having to change too much. We can talk about that later as well.
Awesome.
So let's go into that problem, that context problem. As you kind of alluded to, like when you have lots of MCP servers, lots of tools, you like get a load of like context usage. And so let's say I have the Google Docs MCP, and here it has a bunch of tools. I can get a document, create a document, update a document, all these different things. What most kind of traditional MCP clients will do, including I'll have to admit, like Claude AI and Claude Code today, is they will fetch, they'll do like a tools list call, get all the definitions, and the definitions look something like this. So if you're familiar with the MCP spec for tools, you'll have seen, you know, there's a tool name, there's a human readable title, description, input output schemas, annotations, and sometimes other kind of meta properties that you might want to inject. And so every single one of these tools has this like kind of big definition, and especially these descriptions and schemas can be particularly long, right? If you're like, JSON schema is not a very concise thing, and so if you're trying to accurately describe some powerful set of tools, often you end up like using a bunch of context on these tool definitions. And so that's a problem when you just install like one server potentially with a lot of tools, but then you go around and install like loads of servers, right? Like I personally have, I think about 20 MCP servers that I have installed a lot of the time, and so you have like 20 servers, each with say 20 tools. Now you've suddenly got 400 tool definitions, schemas, etc. in your context. And so this actually is a screenshot of Claude Code I took yesterday, where you can see that MCP tools are taking 100,000 tokens of just definitions. So this, I haven't even started anything. I've just like said hi to Claude, and I can see I've only got 3.9% of the context left of the 200,000 context, which is absurd, right? It basically means that these things are not usable when you start adding more and more MCP tools, unless you're using long context models, but then you have trade-offs against price and speed and other things there. So this is tool definition bloat. And this is like one part of the problem, right? Is just getting all these tool definitions in. But then a second problem is tool result context bloat, where let's say I have a workflow where I was talking with my sales team, and they actually do this quite a lot, where they use Gemini to transcribe their meetings, right? And you get like a nice Google Doc transcript, and you want to take that Google Doc transcript and then basically copy it into a Salesforce record to like keep a record of your customers and put it all together. So with MCP today, in classical clients, the way you would do this is your model would output something like a tool call block, and then your client would see that and then go and call the tool and then fetch the results of the tool and put the entire results of the tool into context. So if this was to get a document's content, it would return that entire, sales meeting transcript, which if it's say a 2-hour meeting, that's about say 50,000 tokens. And so now you've used 50,000 more tokens in your context. And then what you next need to do is the model needs to then call the Salesforce tool, passing in all of that transcript in. And so that's another 50,000 tokens as it writes this entire thing out. So where it writes out these notes here, it's got to write out the 50,000 tokens again. And so you've used 100,000 tokens just to copy, like basically what would take a human copy and paste quickly. A model has to like process 100,000 tokens, which is obviously going to bring costs. It's going to be slow. And if you want to do this in a whole batch, like I have a folder of my meetings over the last week, it's not going to happen in context in any sensible way. Additionally, some models are not very good at just like doing this copying, and so will mess things up by switching numbers around or like making typos, and so it also makes this more brittle. So that is not good. And so yeah, this is a recap. There's this tool definition bloat and tool result bloat. So how are we gonna fix this? And so this brings me to the presentation title, which we're like kind of looking at. Well, models are getting pretty good at writing code. I think most of us will be aware that, oh wow, like coding is actually one of their real strong suits. So why don't we get models to write code to call these MCP tools? In the same way that if I was writing a script and I might use an SDK, I can basically use an MCP server as an SDK over its tools. And so this is just one example of how you might do code execution. And I think there's like a few different ways you can put this together, but here is one that we kind of suggest, where you take each of your MCP servers and you do a tools list call, and then you code generate deterministically. So I'm not saying the model is generating code, but you have some template code that is able to generate these out of the tool definitions, and you generate some MCP like stub code. And so you might also arrange this in a hierarchical fashion. So here on the left, we have a folder tree there's a Google Drive MCP server and a Salesforce MCP server. And then each tool on those servers is a single TypeScript file. And on the right-hand side, we've got an example of one of these TypeScript files, where you can see that we've taken the input schema and turned it into this get document input. We've taken the output schema and we've got a get document response. And then the actual function itself is basically just a wrapper around something that calls up into the main MCP client that calls the MCP server. We then give models a code execution environment in which they can write code that calls this function. And when I say execution environment here, this could be, say, a Docker container you're running. It could be, if you're running, say, Claude Code locally, it could be your machine that you already have that already has some ability to execute code. And actually, this isn't something new or something very foreign. And actually, people have been adding code execution environments to models for a long time. We've known that LLMs, particularly small ones, are not very good at, say, doing maths, right? And so you don't really trust an LLM to do maths. You get it to write some Python code that actually does the calculations, and we execute that. So if you use Claude AI today, I'm sure you'll have seen, if you ask it to do some of these mathematical calculations, it will defer to some Python execution environment. I think the same applies here. One thing to also note here is that we are using a typed language. So in this case, we're using TypeScript. This allows us to use the input and output schemas to make sure that the model's code is actually compatible with how it's wanting to call these tools. This is optional. You can use an untyped language, but we found this does improve performance because then able to self-correct by running a type checker over it first and checking that it's using the tools as expected. So I've talked about the model writing code, and so this would be the code that the model actually generates. So the model writes this code, and you can see it's going to import the Google Drive server and the Salesforce server, and it's able to store the transcript in a variable and then pass that into the update record. Similar to how if you were writing code to automate this is exactly the kind of code you would write. The model can write this code, and now suddenly the model only has to read the tool definitions it actually needs. It can look through that file tree on a virtual file system or however that's structured, look through that file tree, discover the servers that it needs, solving that tool result problem. And then when it executes, it's not storing all the results, the intermediate results in context, and it's able to pass that through directly. And then this would be code that our MCP client executes, runs, and then makes all the calls to the MCP servers with those APIs. So here I have a short demo video of this actually working in practice. So I live in London, as with most of the MCP team at Anthropic. And so you can see I've added this London buses MCP server, which when I've started up my client, it has code generated some stubs, very similar to the stubs that I've shown you before. I think the format's slightly different, but effectively the same idea. And it has two tools. It can find bus stops, and it can find bus departures at those bus stops. And so now if I ask the model, when's the next bus to Old Street Station, it's able to first search over those tools, basically get progressive disclosure as it kind of navigates that file tree, in this case with a sub-agent, to look through the tools and pull them into context. And there you see it's running a container execute tool. So rather than calling the bus tools directly, it's able to write this code. So this is the code that it's written. And you can see it's called that search bus tools, search bus stops tool. It's called the get bus arrivals tool. And it's also written some logic here to be able to, say, slice the results. So if it would be overloaded with, there's 100 buses coming in the next 15 minutes, which is classic for London. You get 100 buses in a couple of minutes and then none for ages. But so it's got that slice there, so it's not overloading its context. And also it can filter for the properties that it's actually irrelevant to it. So again, it's controlling what's going into its context. And so you don't get this tool overload in this context bloat. The other thing it's doing at the end here is it is taking the code that it has written and turning it into a skill. And so not technically a Claude skill, but adding a markdown file would make this a formal Claude skill. But what this is doing is saying, well, I wrote the code once, I know it works, and I've composed these different tools. I've composed the search for bus stops and find the bus departures, and I can write this code and reuse it right in future. So let's see if we can go back. So next time I need to do this thing, I can use this combined tool of busarrivals.ts and just run that as a script. And I can actually import that and then compose that more. So it's kind of building out its own toolkit, its own library of things. And then you really start to get to kind of self-evolving agents, which are figuring out what they need to do, calling the tools to do that, deciding on their control flow and what goes in and out of the context. And then also being able to build up a toolkit of reusable components that get better and better as it kind of does more of these tasks and figures out, okay, right, I should be building a reusable tool for this to make my life easier in future. Yeah. So yeah, just another recap of the problems. Tool definition bloat we solved by having this explorable file tree or some kind of form of progressive disclosure about the tool definitions. We solved our tool result bloat by passing it through variables rather than through the context. But excitingly, there's some bonuses here. So we get this more powerful control flow, which I kind of alluded to earlier, where saying, the model can decide what goes into its context, but actually you get way more power. So in this case, we're using a Slack MCP server to poll a server for poll a channel for updates. And what we want here is we can import our Slack server and just keep waiting until there's something happened. So I don't know if people have used this similar thing. So for example, with GitHub, you would push a change and you want to wait for your CI to pass. What you'd find in most clients is they'll do something like sleep 60 and then check the thing and then sleep another 60 seconds and then check the thing again. All that time is using up context. It's making inference requests off to a server. It's costing you money. And also there's some trade-off between how quickly you can poll. So for example, if you just slept every 1 second, you'd be making API requests every second to your inference provider and using up context. Whereas if it can write code, it can loop over that and just do that directly. Similarly with code, I kind of also said it earlier, but as well as just looping until something happens, you can loop over a file directory. So if we think back to my Google Docs to Salesforce pipeline, if I had a whole folder, Google Drive folder of Google Docs, and I want to do this for every single one, previously it would kind of do them sequentially. It would take ages because it takes 100,000 tokens every single time it wants to do that. Whereas now it can write a simple for loop, maybe do them all in parallel with promises.all, and then runs all of them, done, and it works. The other thing this can be useful for is pre-computing conditionals. So if your model basically knows well, if this happens, then I need to call this thing. If this doesn't happen, then I need to call this. So for example, if there is some error, then I'll need to rerun CI. And if not, I should merge. It can write that as code with an if statement. And then as soon as the first condition triggers, it's able to run on to the next stuff without having to go back to the model and wait for your tokens to come back to the model and then for it to decide what to do next. You can basically pre-prepare all of that to run as one shot. And then also, as we said at the end of the demo video, is you can build a kind of skill library or library of kind of a toolkit of these composable things. And if you want, you can ask Claude to say, right, you've written me this code that you're going to execute to control these tools. We've run it and we know it works. So let's save that onto my disk as a file that I can reuse. And you can add a skill.md and ask Claude to add the skill.md so that it knows how to use this in future. And it can, again, compose and build these tools over time. And then there's an additional thing that's kind of adjacent, and it's not strictly necessary to use code execution with this, but I think this is very closely related to the progressive disclosure of tools. Is this if your user comes in and says, hey, I've got some bug, can you go look around Grafana, Datadog to understand this? If you have that tool available, it's going to be able to find that in the hierarchy, open that file up, understand how to use it, and then actually use it. But if the user doesn't have that installed, if you've got this idea of, well, you can add more tools over time or you can browse tools, you can extend that to external services as well. And so with the open source registry API spec that we released a few months ago, you can then actually search external registries and say, hey, I want to find I don't have a Grafana server, but the user has asked me to do something with Grafana. Are there Grafana MCPs available? It can find them. It can then propose to the user, hey, can we install these? And once it's installed, the client doesn't need to restart because it's just able to look at the file system on disk again and find those tools again and then start using them immediately. So to recap, I think MCP with many tools suffers from these two different types of context bloat that people often conflate, but are actually different: tool definition bloat and tool result bloat. And code execution solves both these problems and more. It can get you solutions to these context bloat problems, but also better control flow and the ability to build out a toolkit of these composed tools. We can also further extend this tool discovery concept to external MCP registries or other MCPs that you might want to install and push that to the user. And additionally, you can read more on the blog, anthropic.com/engineering/code execution with MCP. I'm sure we can probably put it in a YouTube comment as well to save people typing it in. But I think that is all from me. Thank you.
Well done, Adam. Great presentation, and thanks for diving into this in so much depth. Let me ask you kind of maybe the obvious question. So for a person who's already built an MCP, I built my MCP, the classic way. What's the lift here? Like, how much work am I doing to rewrite or adjust my MCP to leverage code execution? And do you think that are there some cases where I should do it and other cases where I shouldn't do it? Like, how do I decide if I'm a MCP author?
Yeah, good question. So I think MCP author can mean kind of one of two things, right? You can be a server author or a client author. And what this means for server devs and client devs is actually kind of different. And so I think for client devs, I would say just go out and implement code execution with MCP. It is almost strictly better in most situations if you're using the latest frontier models. I think if your users are going to be using kind of like underpowered smaller models, then potentially they will get confused with code execution. But I think also you should always keep in mind that like today's models are the worst models we are ever going to have, and they are only going to get more intelligent, and things are just going to be cheaper and faster over time. And so developing for frontier models now is probably okay, because in 6 months or so there'll be kind of like there'll be cheaper models available that can do all this. And so I would say in our internal evaluation results as well of doing this, we find, at least for Opus 4.5, it's just strictly better on all metrics. It uses less context, it's faster, it completes more tasks. So even just not even on context, but also actually achieves more things, and it's able to pass more, achieve the user's intent more frequently when it has access to code execution. For server developers, for most server developers, this means you don't actually have to change anything, because as you saw, you can just it's up to the client to code generate off your server definitions. And so if you already have a server, it will work fine with code execution. If you really want to leverage code execution well, I think structured content and input and output schemas are almost must have if you really want it to perform well. This allows the model to understand the shape of the data it's going to put in and get back much better, especially the data being returned back, and so it can compose it with other tools or do these things like type checking, etc. And the other thing I might say is perhaps also if you're considering editing existing servers, but especially creating new servers, is historically the advice has been make your MCP server use have very few tools that are quite high level, because you don't want to overload the model's context with hundreds of tools. And that you don't just want a wrap around your API. I think this has traditionally been very sensible when everyone has been implementing their clients in this traditional way. When people have tool discovery, progressive disclosure within their clients, and code execution, I think this advice is perhaps much less important. And it's actually more okay to just be a wrap around your API, which actually lowers the barrier to entry to building MCP servers quite a bit, and also can make them more powerful, because your model the model can basically understand all the different facets of your API. So you don't have to say, oh, well, we're just going to focus on the 80% of our most important API. You can actually get 100% coverage and have models do all the things that you want, say, humans to be able to do, or to be able to do it on behalf of humans.
So one logical question that happens is because I've seen this too, where it's like, oh, well, now we can just deal with all these fine-grained MCP servers, because we do see this with organizations that are like, oh, I want to create an MCP server, but they don't know how to do it. If they were to just wrap their API, then they know what to do. But if they're not going to just, if they're going to create these higher level ones, they need to understand the use cases, and then they get lost and they don't know what to do. So it's like, oh, this kind of enables, doing these fine-grained tools. But then if you take it one step further, then the question is, it's like, well, then what is MCP? What if you just, instead of using the Slack MCP that has fine-grained tools, just use the Slack TypeScript client, or, what's the difference? It's like, do you go to the step where it's like, oh, well, why do I even need the MCP servers? What is MCP, providing here? Why even,
why bother, right? If the model can just write arbitrary code and execute it, presumably it can do whatever it wants. I think this is a really good and valid question. And I think there will be some cases where this makes MCP less valuable in edge cases. So for example, I think if you already have great ways for the model to call your API in a composable fashion, it becomes less important. So for example, if you have like the GitHub CLI as an example of, wow, this is actually a great CLI that models really understand well because it's like well documented and people already like, it's in a lot of the training data, and it makes potentially the GitHub MCP less crucial for flows where you have access to an authenticated GitHub CLI, but that's not all flows, right? I think the case actually though for like 90% of MCP servers is actually they're still crucial because they're not like this. You don't actually already have a really nice CLI. You don't already have tons of data, tons of training data in the LLMs about your API, about your the way to call your API, and you also don't have authentication already set up for you. And so MCP gives you documentation, it gives you auth, and it also gives you a reliable implementation that you can actually rely on. Like models are good at writing code, but if your documentation is not quite there, or it's a kind of edge case API or an internal API, models are just not going to know how to do that effectively or reliably. And even if it is a well-known API, if your models are like rewriting an entire API client from scratch for every single request, or at least every single conversation, that's going to burn a bunch of tokens and spend a bunch of time like writing this thing and debugging this, etc. I will say on documentation as well, I think people often underestimate just how important documentation is and I guess context is to LLMs. And having tool definitions and input and output schemas is really crucial for models to do well. I worked in a previous organization where there was this one API, and the only way you could kind of access the API was you emailed someone called Jan, who was a lovely woman, who would send you a big PDF that was like a flattened PDF that had all the definitions of the XML shapes you had to send off to this API. And I think in a world where actually a lot of APIs look more like that than a beautiful, CLI that they're already used to, I think we're going to have MCP to wrap these to have documentation, to have auth, and a reliable implementation against them. And then the final point I'd add is the code execution is like there's a sliding scale with how much flexibility and freedom you can give it, right? Like you could just say, I'm going to let the model write whatever it wants and execute it regardless of like really what's going on in there. But you can also still sandbox it, right? If you run it in, say, a Docker container and you say, okay, you can't have any network access except like the only outbound connections you can have are through my MCP servers, you can then start to apply like enterprise governance policies. You can say, well, actually, like you're only allowed to have AI agents touch these services, or we don't want the risk of prompt injection coming in and our model exfiltrating something out to the random internet. So when you're getting untrusted data, you can only actually use these MCP servers to output things, and MCP gives you a good layer in which you can like enforce these constraints.
So another question, because I know a lot of developers are kind of concerned about like, well, doesn't this mean like it's like every time you make a tool call, AI could do something weird, like you have like, how do you test this? How do you have any degree of like confidence that it's going to work? It's not going to do something strange or whatever. It's like, what do you kind of say to that?
Yeah. I think I would like look towards the numbers and the evaluations. As I said, I think, with Opus 4.5, and I appreciate like, it is one of our most expensive models, but all these benefits I think are going to trickle down into cheaper models that can be faster and better over time. It is just like strictly better on pretty much all of our metrics. And yes, it makes mistakes sometimes, but it also gets it so much more capability that it is usually worth the benefit. The other thing to note is that like tool execution itself is also not perfect. And I'm sure anyone who's used MCP a lot knows that like sometimes models can choose the wrong tools, or they can like put in parameters wrong, etc. And so I actually don't think this is a new problem. I think models are still not 100% reliable anyways. And so yes, you're maybe giving this slightly more capability, like more direction to be unreliable, but it's like the cost benefit is such that actually overall your system as a whole is more reliable at completing tasks that your users actually want to do.
I have a question for you. So you talked about the clients adding support for this. What's the path? I mean, who's added support? Are people already adding support for this? Where are you guys at in terms of kind of adding it to Claude or Claude Code? Do you know if anyone else has added code execution support?
I know there is a PR up on Goose, I believe. They have a PR up basically about to do this thing. I know, of course, we talked about Cloudflare. They have the ability to run MCPs, I think, on workers and other things, or do code execution in sandboxes on workers. And so those are both facets to do this. Within the Anthropic messages API, we have added this capability. So I think it's branded under advanced tool calling. But if you look at our docs on the messages API, we have a guide basically of how you can give us your MCP servers, and we will run the code execution in a sandbox for you, and then send you back the requests, etc. It is not currently in Claude AI and not currently in Claude Code. And I probably can't say anything too exciting here, but it's definitely an area where we're watching and would be excited, I think, to implement when ready.
I mean, there's a couple of things that kind of get like brushed over really quickly that are stumbling blocks with this approach right now. Is like the idea that basically you're generating code and the code becomes the MCP client, where most models, like most systems, are set up so that the LLM or the agent framework is the one that's calling the MCP client. So like when you get into authentication and things like that, there's like a little more things that have to kind of be done to make this work like seamlessly end to end. That like, you know, I do see that it's probably going to make sense that the providers are going to like deeply integrate this approach somehow into their products to handle all the like authentication and stuff like that. Yeah.
I agree. I think the pattern that we've seen, because we have a few different prototypes, and there's also one on my github.com/donomeg/programmatic MCP prototype, I think. I can maybe post that in a bit. But the pattern that we've seen emerging is basically the agent harness is still the one that owns the connections with the MCP client, still does all the auth, and then in this code execution environment, it has a connection to the harness. So rather than it talking to MCPs directly, like the stub function underneath that, where is it? The one that looks something like this, the like call MCP tool, like this is some helper that's like goes and talks to your harness, and like the harness then goes and sends off those connections.
Yeah. So there's something that has to kind of go on kind of at that layer, because we've been looking at that too, because like we've been fooling around with the idea of basically creating an MCP server that then just does this pattern. So it's an MCP server that calls another MCP server, which then gets into the heart of a lot of these agentic identity issues and stuff, where it's like if you have one MCP server that calls another MCP server, how do you carry through authentication and stuff? And there's actually some interesting patterns we figured out with like URL solicitations and things like that. But I'd be kind of curious to see if this kind of harness thing, this call MCP tool, kind of gets standardized in some way of like, oh, well, this is a way that I can determine that I need to make that call. So yeah, it'll be interesting. So I think like this, you know, this whole pattern is when code mode, like I think what was Cloudflare maybe was when they announced there's like my initial reaction to it was like it was like it was like basically like we're pretty much just proving that tools have to be agentic. That's kind of like, you know, it's like the solution is it's not just kind of like writing more code. It's like the only way to solve these problems of basically context, bloat, and all these things and whatever is like we really have to lean into AI more. So like, because I was asking like, what do you think about like the reliability and stuff like that? Because like I see a lot of engineers push back on these things of like, no, you know, you can't, you know, like it's not going to work.
Outcomes. Yeah, you're not going to guarantee outcomes, right?
Yeah. But it's like, but I think that's the thing is like as engineers we have to kind of go away from where it's like, you know, if you can like reliably, you know, kind of. There's other ways to get this to predictably work, that there is already actually less reliability than you kind of already assume. So we're focusing on the right, because like I don't know that this code execution is like necessarily like the silver bullet, but this whole idea of like basically allowing AI to make more decisions on what to do and dynamically generate and whatever, it's like leaning more and more into AI where it's like dynamically determining, like as you said, like like the code flow, the fact that it can do loops and branching and stuff, like it determines that all up, you know, itself. So I think it's just fascinating where this stuff is going, where it's like more and more the solutions to how to make this work is actually less. It's kind of like less fancy traditional engineering code and more just patterns in AI. Like how do we create better patterns with AI to do things in kind of like predictable, eventually predictable ways.
Yeah, I agreed. I think definitely because if you've already got a model, right, you can write code and then just see the results. If it throws an error, you can iterate and get the model to fix these kind of problems.
Yeah.
I will say that you can take this another direction, still with code execution, and actually still push towards the deterministic outputs, more with the kind of skills thing I was alluding to at the end, where you get your model to write code, and then if you wanted to, you could just treat this as production code. You could add unit tests to it, you could code review it, you could make sure this thing works, and then you start to build up this toolkit of more composable tools for your AI systems to use, and even in some extreme cases, you could get to the point where, an AI agent has looked at a whole system, understands how everything goes together, and it's right, I'm going to build all this workflow, right? And it builds a fully deterministic workflow that you just run. You even no longer run the AI. It's just a full. If you want a workflow of copy my Google Docs from this folder to Salesforce, it writes that code, and now you can just run it without the AI at all. And you've got this deterministic code that you can version control, test, review, etc.
I think the thing that always bugs me though is because I think what you're saying is absolutely right, but too many engineers will just immediately go into oh no, I wanted to do that, so immediately generate make it deterministic and then just always use that over and over again. But that's a very difficult problem because you can basically look at this as it's pretty much JIT. It's as this gets more and more evolved, you can say oh, having the LLM dynamically generate code and execute is interpretation, running in an interpreted mode. And then once you identify certain patterns are being done over and over and over again, then you can kind of solidify that and turn it into. But the problem with solidifying it is it's how do you actually know that code that was generated was actually correct? That's the one you really want to stamp it. So you can do it out of band of generate this skills once, but that only works for that one use case. What you would really want, and I think this is where I would say this would go, is that you get more fancy about oh, generate code, and if you observe this also with AI, you get enough oh, this pattern is very common, and then you can actually then just kind of use AI to make sure okay, well, is the code good, whatever, then solidify that, and then that becomes a hot path going forward, where it's oh, I can just skip the LLM. So it's
I feel like we could talk about this for an hour, guys. Yeah. I do think we need to wrap. Adam, thanks so much for coming on and sharing all this. It does seem like we're, the reality is this is going to happen over time as clients add capabilities, as MCPs get rewritten. I hope we'll have you come back and maybe kind of keep talking about this journey, because I do think it's pretty interesting and one that's pretty central to the success of MCPs as kind of the next year goes on. Darren?
I would throw out just one practical thing or whatever is I think this is solving a lot of issues that are these are all very forward leaning. For a lot of use cases, people the tool set is already small. You don't want dynamic, so it's so this is still very much in the, all of this is bleeding edge, but this is in the bleeding edge of the bleeding edge. So it's should you adopt code execution right now? I mean, I'm not so much on the I think everyone should immediately use it. I think it is definitely kind of the future, but for a lot of pragmatic things, if you're doing something right now, it's still a little bit too far ahead because of a lot of other issues with authentication and, so. But I think it's a very, very, I think it's basically the future, because tools have to become agentic for all this stuff to work. So, but yeah.
Adam, thank you so much. Really appreciate you coming and joining us today.
Thank you so much. It was lovely. And we'll be pleased to come back some other time.
Awesome. Take care.